The inexplicable discoveries made by the James Webb Telescope have left astronomers completely baffled. Instead of deepening our knowledge of the universe, Webb's findings reveal a disturbing fact. Our understanding of cosmology is simply not sufficient to explain the nature of the early universe. And where the tried and tested Big Bang theory has clearly had its day, new theories of creation must be developed. But why is this once sacrosanct idea now coming under increasing criticism? And above all, what is the alternative to the Big Bang? Stay tuned until the end and join us as we get to the bottom of this fascinating topic. Even those who are not particularly interested in astronomical research know that everything began with the Big Bang. But what does that actually mean? How did the birth of the cosmos unfold in detail? And how can we even know this so many billions of years later? Well, contrary to initial assumptions and some descriptions, the Big Bang was not an explosion into an existing space, but rather space itself, which emerged around 13.8 billion years ago, together with time and matter from an original singularity. This singularity in turn describes a point or state of infinite density, temperature and spacetime curvature, and thus a place where the known physical laws of general relativity reach their limits. But when it comes to the question of how we can know this today, experts point to a characteristic that the universe has possessed since its inception. It is expanding. Ultimately, however, this discovery is still relatively recent. After all, it was less than a century ago that Edwin Hubble proved that the Milky Way is not the only galaxy in the cosmos and that the other galaxies are actually moving away from us. The cosmological worldview of an unchanging and eternal universe was thus overturned practically overnight. But even in this case, it is not the cosmos that is expanding into an existing space, but space itself that is constantly growing larger. And what all this has to do with the Big Bang becomes clear when we look at this process in reverse. In this way, experts are able to calculate backwards to a point where the density of matter and energy is infinite and all spatial distances are zero, thus reaching the cosmic starting point. The proof of cosmic microwave background radiation is considered outstanding evidence for the correctness of the Big Bang theory. This is a remnant of radiation that originated about 380,000 years after the Big Bang during the recombination epoch and still fills the entire universe today. However, it should be noted at this point that the Big Bang theory does not explicitly deal with the actual birth of the universe, but with the immediate phase after it. More precisely, experts are dealing with a timescale ranging from the so-called Planck time around 10 to the power of -43 seconds to 400,000 years after the Big Bang. And although we have no idea what the universe looked like before the mysterious Planck time, the Big Bang theory still holds an unshakable position in the standard model of cosmology. This makes the situation all the more complicated when researchers discover something that simply cannot be reconciled with our established models, and that even causes some to critically question everything we thought we knew about the origin of the universe. Webb's impossible discoveries. According to conventional wisdom, the first stars shone about 200 to 300 million years after the Big Bang, ending the so-called Dark Age. However, it is uncertain exactly when the stellar sparkles first coalesced into fully fledged galaxies and how quickly they grew. Some of the first images captured by the James Webb Telescope provided an important clue to solving this mystery. In July 2022, experts announced that Webb had detected a series of galaxies, some of which existed just 300 million years after the birth of the cosmos. Compared to the structures that emerged in the following millions of years, these were still significantly smaller and less massive, perfectly in line with experts' expectations. And that was only logical. After all, the density of matter in the young universe was simply not yet sufficient to form galaxies the size of the Milky Way. Or at least that's what people thought until then. What began as the discovery of 6 inconspicuous reddish shining points of light would ultimately trigger the greatest astronomical crisis of our time. But what had happened? Well, it's quite simple. The points of light turned out to be very early galaxies. And although they existed only 500 to 700 million years after the Big Bang, they were already almost as massive as our Milky Way is today. Instead of encountering the predicted galactic dwarfs, Webb identified structures that, according to our understanding, should not even exist. This circumstance seemed so incredible to the scientists responsible at Swinburne University of Technology in Melbourne that they suspected they had made a mistake. But this suspicion was not confirmed in the course of detailed follow-up investigations. On the contrary, data analysis showed that the early galaxies already contained more than 10 billion stars, and in one case even more than 100 billion with a mass equivalent to that of the Sun. And since, according to our theories, There simply wasn't enough normal matter available so soon after the Big Bang to form so many stars. These objects stand in stark contrast to virtually all current cosmological theories and thus earned themselves the infamous nickname universe breakers. In order to explain the existence of these structures, the density of matter in the early cosmos would have had to be up to 5 times greater than previously assumed. The other not much more illuminating explanation is based on the idea that the galaxies formed in a way that is completely unknown to us. But that was only the beginning. The Big Bang debate. The bottom line is that the discovery of the universe breakers was not a confusing isolated case, but merely the prelude to a whole series of similarly puzzling Webb findings that literally scream that something is wrong with our standard model of cosmology. In addition to other early galaxies that appear far too developed for their age of a few 100 million years after the Big Bang, Webb also found early supermassive black holes that also appear much too large. In addition, it identified several elements in the early cosmos that, according to the Standard Model, should not have existed yet and confirmed the so-called Hubble tension, or in other words, the fact that the universe is expanding much faster in reality than it should theoretically be. It is therefore almost impossible to deny that our understanding of early cosmic development is incomplete. However, some researchers locate the root of the astronomical dilemma even deeper and believe that the universe did not ultimately originate within the framework of the much-cited Big Bang. And even the experts who continue to adhere to the Big Bang theory cannot avoid admitting that this fundamental theory is accompanied by a number of questions to which we simply do not know the answers. These include, in particular, the questions of why and how. How is it even possible that something emerged from literally nothing 13.8 billion years ago? Can anything emerge from nothing at all? And was there a trigger for this? Or was it mere coincidence? Well, Stephen Hawking took a clear stance on this, stating that the question of what came before the Big Bang was just as nonsensical as asking what is north of the North Pole. Since time itself only began with the Big Bang, this process could not have been triggered by anything or anyone. However, some researchers have problems with this idea, and no less controversial is the question of the strangely uniform radiation and density in the universe. No matter in which direction or how far we look, on a large scale, there are similar densities and distributions of galaxies, nebulae, and radiation everywhere. Many experts explain this with cosmic inflation and thus with a phase of extremely rapid exponential expansion in which the universe expanded by a ludicrous factor in tiny fractions of a second after the Big Bang. However, whether cosmic inflation really took place is partly controversial, but some experts take up this assumption and spin it a little further. Alternatives to the Big Bang. According to chaotic inflation, it's conceivable that this process only came to a halt in a few bubble-like subareas and otherwise continues forever. This also means that a separate sub-universe forms in each bubble, whereby each cosmic world can contain its own individual physical laws. In this context, our cosmos would not encompass the big picture at all, but merely represent a tiny link in an endless chain of universes. No less exciting is the idea that our universe is by no means unique, but that we emerged directly from a predecessor universe. According to the corresponding Big Bounce theory, words such as beginning and end are meaningless in a cosmic context. In other words, what we commonly refer to as the Big Bang was in fact nothing more than a cyclical transition. For as soon as one cosmos dies, a new one emerges from it. And as a result, the universe, which in this model is part of a multi-dimensional structure, is subject to an eternal rhythm of destruction and resurrection. And yet, these are by no means all the alternatives to the conservative Big Bang theory. According to this theory, an article appeared in NASA's Cosmic Times in 1955, which stated that there was never a Big Bang simply because the universe has existed for an infinite amount of time. The supposed expansion of the cosmos is also a fallacy. The constant formation of matter merely gives the appearance that the universe is expanding incessantly. However, the most exciting and controversial theory of creation comes from the world of quantum physics and string theory. Experiments have allegedly shown that the universe and everything in it does not actually exist at all. Put simply, what we perceive as the visible universe is nothing more than a flat hologram projected onto a sphere. Consequently, it's possible that we, along with our reality, are the result of a higher-level simulation. And what at first glance sounds like the plot of a crazy science fiction movie can actually be reconciled with the so-called Kardashev scale. This categorization indicates how far a civilization has developed based on its energy use. If there really is a Type 3 civilization capable of harnessing the total power of a mature galaxy, It may have succeeded in creating a perfect simulation with the help of a so-called matryoshka brain. But whether we would really want to know the truth in this case is of course another matter entirely. And hopefully you've added subscribe to your to-do list. Join our community and never miss another video from our channel The Science Signal. We'll see you soon.